Today we are going to look into how do I find the complex root of a quadratic function. So first thing, you need to make sure that your quadratic is in standard form. Standard form is usually as a x squared plus b x plus c equals to 0. You have the ax squared here, bx. Okay, so we're going to bring the negative 9 on this side. So let's rewrite this. This is going to be 2x squared plus 8x plus 9 equals to 0. Okay, next thing we're going to do is use the quadratic formula to solve this in. And we know the quadratic formula usually is x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. But I need to know my a value here. A value here is 2, b value is 8, c value is 9. Okay, I'm going to just substitute this into the formula. Be super duper careful. X equals negative 8 plus minus square root of 8 squared minus 4, a is 2, c value is 9, over 2a is 2 here. So negative 8 plus minus 8 times 8 is 64, 4 times 2, 8, 8 times 9, 72. Over 2 times 2 is 4, and this will give us negative 8 plus minus square root of negative 8 over 4. So I have square root of negative 8, so I'm going to bring out the imaginary number I plus minus I radical 8 over 4. What is radical 8? Well, we can simplify it a little bit. I know that 4 times 2 is 8, so 2 squared is 4. 4 times 2 is 8 over 4 here. This would go goodbye with this, so we'll have it outside. Plus or minus, I'm going to take out the 2 and then the I, radical 2 over 4, which will break down to two solutions. So negative 8 plus 2i radical 2, and they're sharing the denominator to be common, so negative 8 over 4 and 2i over 2 over 4. Okay, or negative 8 over 4 and the minus 2i radical 2 over 4. Let's simplify these. This happens to be 4 goes into 8. How many times? 2 times, so negative 2 plus 4 goes into 2 here. How many times? 1 time, so this is 2. So I'll have I radical 2 over 2, or this is negative 2, and 2 goes into 4 2 times, minus I radical 2 over 2. And this is my solution, which can be rewritten as negative 2 plus or minus I radical 2 over 2. So really the whole idea is for us also to know that when our discriminant, which is b squared minus 4ac, if this is equal to 0, then there's only one real solution. If this is greater than 0, then there are two real solutions. But if this is greater than 0, then there are two imaginary or complex solutions, you want to say. There are two complex solutions, and that's what we found here. And that's pretty much it. Just be very careful with your organization and just stay consistent. And if you have any questions, feel free to ask. Thank you for watching.